In this video, I'm going to show you the basics of PLC programming without a VFD variable frequency drive. So as you can see, I have push buttons and a set of LEDs and a relay and a PLC. So this is our programming software, Logosoft Comfort version 6. It's a bit outdated, but it still does the job very well. The most common IOs used is the output, the input and the output. And as you progress, you will move to analogs, function blocks, special functions. You have your on delays, relative on delays, counters, and then more analog and miscellaneous. All right. So now I'm going to demonstrate the use of a push button now. Let me download. Okay, then I come here. All right, so now with the push button, whenever you press the push button and hold, the circuits connect and your LED goes on. And whenever you release the push button, also disconnect the circuit. And it looks like this. Whenever I press, the LED goes on. When I release, the LED goes off. Okay. This, it's not ideal whenever you need to program, because it means whenever you press the push button, you will make the machine to run, and as soon as you release it, you will make the machine to stop. So the big question is, how do we then make sure that we retain the signal from the push button? Then we return it like this. Press escape or stop. Okay, escape, and then delete the connection, put the latching relay, then connect there on S stands for set, then connect to your output. After that, connect the second push input. All right, and then this one is connected at R. Let's do this. Help. So as you can see, there is a set here on connection, set output Q with a signal at input S. Then this one reset the output with a signal input reset. So what it does, it retain. It's a retaining memory. So its function is to set memory. All right, and it always prefers the reset comes over the set. So basically, when the set and the reset are pressed, the latching relay will only consider the signal from the set. So the reset overrides the set signal. Okay. So now the circuit looks like this. When I download it, okay. So now I press I1, okay. Q1 goes on, then I press I2. As you can see, Q1 goes off, and then on my screen here, when I literally press I1, the green LED goes on, and when I press I2, the green LED goes off. So one person can ask, but why shouldn't we use switches that switch from 0 to 1 instead of the push button? So the disadvantage of that now is if we were using switches, these are switch, they are connected similarly to our inputs here, the push button. So when I press the switch, it retains by itself there, it retains the position that you placed it on, and whenever, and the latch will switch on. As you can see there, the latch is on. But now let's see when we go to the reset button. When we reset, indeed the reset overrides the set, but now when you release, it switches on again. Why? Because the signal at I1, it's constant. So if I1 is constantly pressed, even if you press I2, that signal will remain there. So this simply means that utilizing a switch is very disadvantageous. As you can see, when I press I2, for as long as I'm holding up the I2, Q1 will switch off. As soon as I let go, Q1 turns on again. And if this was your emergency stop button in a very complex machinery, you were going to be having some serious problems where whenever you press the push button, the system will still be active. The stop button, the system will still be active, and that will can endanger a lot of lives. So it is not best to use the switch as instead of a push button. You need to use a push button to start your initial process. You can use the switch to enable, and then use a push button to start the actual machinery and stop it successfully with a push button, with an emergency push button. And then in some instances, you might be required to wire the stop LED indicator whenever the machine, after you have pressed the stop button, it needs to symbolize with a red indicator. So to do that, you need to put Q2, because according to the wiring, Q2 is our second LED. Okay, so you put the output. As you can see, I'm taking the output, and you need to take a latching relay also. Okay, and then now whenever we press I2, we are expecting Q1 to stop through the RS there, and we're expecting Q2 to switch on, the stop LED to switch on through the very same pattern. And we are expecting, whenever we therefore restart the process, we are expecting the red light to switch off using I1 and the green light to come on. Right, so now whenever I switch on, the green light goes on, then whenever I switch off, the red light comes on, to symbolize that there is a problem. And we can also incorporate a buzzer to buzz whenever the machine stops. So the buzzer, according to the machine, the buzzer is Q4 according to the circuit that we are using, the training kit, and we're gonna connect it like this. Right, and then okay, let me get there. Right, whenever we start the process, Q1 switches on, and whenever we stop, the buzzer goes on also. Alright, so let me show you how it appears on the screen. Q1 is on, and then Q2 is on also with the buzzer. Okay, and then if we want a delay, if we want the process to be delayed for some couple of seconds before it goes on, we can therefore place an on delay there. Okay, and put your 2 seconds. So now this delay will function on the space of, whenever you trigger the latching relay, it will count for 2 seconds, then it will enable the Q1 to power on. So this is how it looks like. Whenever this, then the timer goes on. After that, the LED is on, and then the buzzer there. I'm just gonna remove the buzzer because it's a bit noisy, and I'm gonna therefore transfer this one without the buzzer and show you how it looks like. Okay, and then you see there's a delay, then it switches on, and then when we reset, it switches on off immediately. But now the on delay might make the circuit look a bit complex. We can therefore, instead of using it, we can then use the tentative on delay. So on trigger, we place this, and then always press escape to make your life a bit easier. Okay, this connects with that I2. Okay, then that there. Then now we download. Okay, I forgot to put the timer. Timer is very critical. We need 2 seconds. So as you can see here on the formatting, it says it's seconds before, and then after that it's one second is 100 milliseconds. So this side it goes until 100, and then this side goes until 60. So yeah, so we're gonna do 2 seconds again. Okay, so we need to also show display there. When I press the push button, after 2 seconds it goes on. So this one is a relative on delay, is the same as the thingy, the relative, the latching relay. So as you saw the previously, the definition there on the parameter on latching relay, it stated that it retains the relative. So this one's relative and on delay on the same circuit. So it's a combination instead. Okay. So this is how it looks like. Whenever you press, it delays for 2 seconds. After that, it switches on. Then after that, it resets. So these are the basic programming program that you need to use to test anything. You need to make sure you put on your push buttons and your LEDs. Then you put on your latching relay, and don't use the switch. Instead, use it as an enabler to enable your whole process, and then use the push button to program. And this basic program, you can develop it according to the number of inputs you have, the number of outputs you have. You can draw a very complex program out of this one that is very complicated, but for as long as you understand that you need a latching relay or a relative on delay to latch or to retain your signal until a certain input is pressed. Therefore, you will be able to program any machine you will come across. Thank you so much for your time.